So this is what this transfer function will look like with the denominator resolved. It is not exactly, but this is approximately like this, right? Or perhaps exactly 20s plus 20s and yeah, this is approximately because this. So that omega n is nowhere over here, even if we say we got a second order dominant system. And we got this pole as well. Where are the poles of this? The pole of this omega n is, and it got some damping in it as well, right? It got some damping in it, and we got this omega n. But 20 square root omega n is equal to 20 square root, and it will be less than 4. Omega n will be less than 4, right? Oh, greater than 4, in between 4, 4.5 approximately, right? So one criteria is this: you compare this with the required omega n, and omega n should be greater than 2.22, right? But a better way to handle a higher order system is something else. A better way is the which can give some better answer or better verification that the system will have a settling time of same as required. So how we can verify that? We can verify that by using analyzing the closed loop system. And from open loop transfer function to closed loop transfer function, remember we did Nicholas plot. We'll discuss Nicholas plot how we will discuss it later. But before that, let's see what is the, if we have a second order system, what is the bandwidth corresponding to this omega n, and we want a damping ratio of 0.45. So if somehow we got this omega n and we have a damping ratio like this, then what will be the bandwidth? Remember these plots. You remember these plots? Second order system with the damping ratio, the Bode plot of closed loop system look like this. And smaller is the damping ratio, higher will be the peak. Right? And what is the bandwidth? Bandwidth is the characteristic of closed loop system. This system has a larger bandwidth. This system has smaller bandwidth. Bandwidth is the value of the frequency where the output of a system becomes 3 dB lower than the low frequency response. And low frequency response is 1. So bandwidth is, this is the normalized curve. So low frequency response is 1. Basically, these are the curve for omega n square over s square plus 2 zeta omega n s plus omega n square. So low frequency response is 0 dB, which is 1, right? Putting as 0, this is ratio omega n over omega n square is 1. So at this damping ratio, this is the bandwidth. At this damping ratio, this is the bandwidth, this is, right? So closed loop system bandwidth is, for a second order system, we can calculate from this easily. If omega n is 2.22 and damping ratio is 0.45, what will be the bandwidth? Remember, we can, the relation between the omega b and damping ratio and omega b over omega n, just to normalize it. It was discussed in 8th chapter, and we can relate the bandwidth of the system to the damping ratio, and that is given in chapter 8. And let me open that and I'll show you the relation.